Welcome back to the Get Willy computer classes, that is learning computer with seeing the natural beauty of Indian village. And now I am today with a new topic, or in this module you will learn about the processor and memory. Some word is chirping. So in the processor and memory, let's talk about this. In the previous module, we saw that the main component of a computer systems are input, output, storage and CPU. We also saw that the storage units are of two types, primary and secondary. With this knowledge, now we are ready to learn more about the internal structure and functioning of various components of a computer system. These lectures are devoted to the learning of components of the computer. In this lecture, you will learn about the structure of functioning of CPU, also known as processor, and primary storage, also known as main memory or simply memory. Now first we know about the central processing unit, CPU. CPU is the brain of a computer system. It performs all major calculations and comparisons, and also activates and controls the operation of other units of the computer system. Hence, no other single component of a computer determines its overall performance as much as its CPU. In order to evaluate a computer's capabilities quickly, it is important to know how CPUs are internally structured, how different CPUs differ from each other, and how to evaluate CPU speed. These and other related concepts are described below. Here you can see the structure of our computer system. This is the rough structure of a computer system. See. Now let's talk about control unit. First we talk about control unit in this lecture. We saw that the two basic components of a CPU are control unit, also called CU, and arithmetic logic unit, ALU. The control unit of a CPU selects and interprets program instruction and then coordinates their execution. As figure shows, as in the previous figures shown, it has some special purpose registers whose functions are described in a later subsection, and the decoder to perform these activities. These special purpose registers named instruction register and program control register respectively. hold the current instruction and the next instruction for execution, and in this way help the control unit in instruction selection. On the other hand, the decoder has necessary circuitry to decode and interpret the meaning of every instruction supported by the CPU. Each instruction is accompanied by microcode, very basic directions that tell the CPU how to execute the instructions. Although the control unit does not perform any actual processing of data, it acts as the central nervous system for all other components of a computer. It manages and coordinates the entire computer system, including its input and output units. It obtains instruction from a program stored in a main memory, interprets the instruction and issues signals that cause other units of the system to execute them. Now we will learn about the arithmetic logic unit, ALU, which is called ALU, arithmetic logic unit, or ALU. Cap ALU. Cap means in capital letter you have to write ALU. This is the convention for abbreviation. You take word letter as a capital. So see the natural size here. Now let's see. Again you see the Indian. Oh no. Arithmetic logic unit, ALU. ALU of a CPU is the place where actual execution of instruction take place during data processing. When the control unit encounters an instructions that involves a arithmetic operation like add, subtract, multiply, divide, or a logic operation such as less than, equal to, greater than, it passes control to the ALU. The ALU has some special purpose registers, whose register have registers and necessary circuitry to carry out all arithmetic and logic operation included in the set of instructions supported by the CPU. For example, control unit might load two numbers into ALU register and then tell the ALU to add them or to check if they are equal, a logical operation, and add means a arithmetic operation. Now instruction C. When entire CPU, both CU and ALU is contained on a single tiny silicon chip, it is called microprocessor. That is, in microprocessor both CU and ALU is contained. Now instruction set. Let's learn about the instruction set. Every CPU has built-in ability to execute a set of machine instruction called instruction set. Most central processing unit have 200 or more instructions such as add, subtract, compare in their instruction set. The list of instructions supported by CPU in its instruction set forms the basis for designing the machine language for central processing unit. Since each processor has a unique instruction set, machine language program written for one computer will generally not run on another computer with a different CPU, central processing unit, or CPU. CPUs, central processing unit, means CPUs made by different manufacturers have different instruction set. In fact, the different central processing unit models of the same manufacturer may have different instruction set. However, manufacturers tend to group their CPUs into families having similar instruction sets. Instructions. When they develop a new CPU, they ensure that its instruction set includes all instructions in the instruction set of its predecessor's CPU plus some new ones. This manufacturing strategy is known as backward compatibility, and the new CPU is said to be backward compatible with its predecessors. This feature allows software written for computer with a particular CPU to work on computers with newer processor of the same family. In turn, it allows users of these computer systems to upgrade their system easily without worrying about converting all their existing software. Now then, in this lecture, our next topic is registers, and we will know about the register in the next lecture.